I first noticed the bridge in November, walking along the north embankment of the Vltava, near Karlin district, Prague, where official records claim the Stvanitz service bridge was completed in 1898. I had come only to examine a minor renovation file from 1924, referenced in an engineering journal stored in the Prague Municipal Archive. The photograph attached, grainy, labelled Preliminary Inspection of Substructure, 1899, showed a modest steel truss resting on stone piers consistent with late 19th century industrial work. Yet standing beneath it, I ran my hand across the base of the eastern pier and felt something the photograph did not capture. An impossible smoothness in the granite, a curvature too precise for the hand-dressed stone blocks represented in the period documents. The symmetry was absolute, radius consistent to the millimetre. It echoed patterns some researchers now classify as Tartarian substructure geometry. I told myself it was nothing, but something about the curve felt older, hidden beneath the official century. According to municipal construction records, work on the Stvanitz service bridge began in March 1896 under the supervision of engineer Karel Vlasak, whose notes describe routine challenges, shifting river levels, occasional supply delays, and the difficulty of anchoring temporary scaffolding on the island's southern bank. Everything about the official narrative presents the bridge as unremarkable industrial-era engineering. I began with the standard sources, the 1898 completion certificate, the 1897 progress photographs, and an early 1902 maintenance report citing erosion around the western footing. The photographs depict familiar elements: steel trusses, riveted joints, workers in wool coats standing among timber supports. And yet one of the earliest images, dated August 1896, troubled me. Beneath the construction platform, the stonework already appeared fully formed, showing a finish that no record of the construction process mentioned. The eastern pier in the photograph displays a clean concave profile, glossy even in monochrome. But the construction journal written by Vlasak states, "Rough blocks delivered from local quarry, final finishing after installation." What I saw in the photograph did not match that description. The radius was perfect. Archival measurement suggests 4.27 meters, a curvature repeated identically on all sides. Repeating radii in stonework of that era typically reveal machining beyond handheld chisels, yet there is no mention of pneumatic tools on site until at least 1908, and no evidence they were used here. I compared the pier's curvature to architectural motifs mapped in regions labelled Great Tartary on 18th century atlases. The resemblance was uncomfortable. The same mathematical precision, the same glossy finish, the same impossible symmetry appears in structures across territories once marked as Tartarian on pre-1800 European maps. My final note of the day was brief. If these stones were carved in 1896, where are the tool marks? A small question, but it pressed harder than it should have. When I returned the following week, I focused on the lower substructure, which is ordinarily accessible only during low water. According to the 1911 renovation ledger, a maintenance alcove beneath the eastern approach had been sealed due to lack of functional purpose. The ledger includes no schematic, only a one-sentence entry by Inspector A. Novotny. Interior void filled and bricked to prevent trespass. Yet a 1903 bridge inspection photograph reveals a rectangular opening at the same location, framed in stone whose precision stands out even against the bridge's otherwise utilitarian design. The edges are flawless, no mortar extrusion, no settlement cracks. The lintel appears to be a single monolithic block, possible to lift without substantial machinery. Inside the photograph's shadows, a circular metal component is faintly visible, perhaps a pressure valve. But pressure valves have no purpose in a pedestrian service bridge, and no such installation is described in contemporary engineering logs. I found a renovation plan from 1924, drawn decades after sealing, which references removal of unclassified cast iron fitting. The attached sketch, though crude, resembles the type of valve associated with hydraulic regulation systems found in older European waterworks, systems occasionally linked by alternative historians to Tartarian infrastructure networks that supposedly spanned continents before the 19th century. The sealed doorway's proportions are also mathematically exact, 2.1 ratio, matching doorways found in buildings across cities once included in older maps of Tartary. Whether coincidence or inheritance, the pattern unsettles. I left with a single observation circling my mind. The official records insist this alcove had no purpose. Yet someone installed a pressure valve inside it. The turning point came with a blueprint dated February 1897 labelled Substructure Detail, Eastern Pier. Its paper had browned unevenly, the ink faint. The drawing depicts standard footing geometry but contains a faint, erased element beneath the pier, barely visible, a circular chamber aligned perfectly with the river's current. Using raking light, I photographed the blueprint at high angle. The erased chamber showed a diameter of approximately 6.8 meters, far larger than necessary for a footbridge foundation. Chamber structures of this type belong to hydraulic or pressure-regulating systems, not pedestrian crossings. But the official blueprint approved by the City Council contains no such chamber. Its removal appears deliberate, not accidental. A marginal note survives on the erased area, existing cavity to be surveyed before reinforcement. That single word, existing, contradicts all construction narratives asserting the substructure was built from the ground up. If the cavity pre-existed, the 1898 bridge may merely rest atop something far older. And the chamber's proportions, perfect circle, heavy central axis, evoke the domed hydraulic rooms seen in other structures alternative researchers classify as Tartarian hydraulic stations, part of a continent-spanning water management system allegedly predating modern industrial capability. My final note was simple, but heavy. Why would an 1896 blueprint describe a cavity that the official record claims did not exist? The archive staff retrieved the photograph reluctantly, an oversized plate print stored in a brittle cardboard sleeve, labeled simply Stvanitz Substructure 1896-97. No one had requested it in years. The negative had been digitized, but the digital copy lacked the depth of the original. I insisted on seeing the print. What emerged beneath the sleeve was clearer than I expected. In the lower right corner, a handwritten notation reads, Survey of Lower Platform, November 1896, Haverda. That name appears in the project logs. Antonín Haverda, a site engineer responsible for preliminary inspection before the formal start of construction in early 1896. The photograph shows the river frozen at its edges, the waterline lower than usual. Wooden planks lay scattered on the mud, and in the center stands the eastern pier, already formed as a complete stone mass months before any record claims construction began. Haverda's own journal states, "We begin foundation work March 3, 1896. But the photograph contradicts this directly. More troubling is what stands behind the pier, a section of exposed masonry, curved and polished, extending below the known footing depth. The exposed curvature matches the radius I measured at the site, 4.27 meters, precise beyond expectations for early phase construction. When enlarged under the microfilm lamp, I noticed the faint outline of a recessed channel running vertically along the stone face. It is too regular to be a crack. Similar vertical channels appear in hydraulic structures, sluices or pressure-modulating systems found in far older sites across Eastern Europe. The resemblance to motifs I'd seen in drawings of Tartarian hydro-architectural remains was unmistakable. Researchers studying Tartarian infrastructure often point to these vertical channels as signatures of advanced water distribution networks. Why would an unfinished pier in 1896 show design language associated with far older hydraulic systems? I searched for any annotation referencing this exposed masonry. The back of the photograph bears a faint impression, perhaps from another sheet pressed against it for decades. I traced it with gloved fingers. Existing stonework stable incorporate into final foundation. That word again. Existing. I left the archive unsettled. A bridge officially built in 1896 seemed to have inherited a stone base that no document acknowledged, and the style of that base echoed structural elements found on maps of regions once labelled Tartaria. The contradiction deepened, quietly but irrevocably. I located the journal by accident while reviewing unrelated materials on municipal waterworks. The binding was faded, the pages uneven. Its title, Notes on Urban Hydraulic Infrastructure, compiled by engineer Victor Ndoma, dates to 1889, 7 years before the bridge's construction. Most entries concern routine maintenance, pump installations, and stormwater issues. But an entry near the back describes a survey conducted around Štvaníč Island, noting subterranean cavities of unknown purpose aligned with anomalous stone formations near the riverbank. One passage stands out: observed chamber under east point of island, circular, finely dressed stone, appears older than adjacent masonry, no known record of construction. Recommends sealing until function is determined. This predates the official construction of the Štvaníč Bridge by nearly a decade. If a circular chamber existed before 1889, it could not have been part of the 1896-98 bridge project. And the description, finely dressed stone, perfect curvature, unknown purpose, aligns too precisely with the erased circular chamber on the 1897 blueprint. I cross-referenced Ndoma's notes with the 1911 renovation ledger. The terminology shifts, but the underlying observation matches. Removal of unclassified iron component from lower alcove. This suggests at least 2 generations of engineers encountered the same inexplicable substructure, first as a chamber, later as an alcove, eventually sealed and ignored. The deeper I read, the more I felt the narrative shifting from construction toward inheritance. The chamber's design echoes circular hydraulic rooms identified by some alternative researchers as Tartarian pressure domes, a form of distributed hydromechanical architecture claimed to predate industrial engineering. These domes allegedly formed nodes in a Tartarian continent-wide water regulation network, managing flow and pressure across vast distances. Official history dismisses such connections entirely, yet the similarities once noticed are difficult to unsee. Material analysis strengthens the contradiction. Ndoma describes the stone as exceptionally smooth, hardness above typical local granite, but no quarry in the region produced such material in the 19th century. My quiet note at the bottom of the page reads simply, if this chamber predates the bridge, who built it? And why does its geometry match structures far outside Prague, across areas once labelled Tartary? The line between official chronology and physical evidence was beginning to fray. By midwinter, I had widened my search beyond Prague. If the Štvaníč Bridge truly rests atop inherited substructures, similar patterns might exist elsewhere, hidden beneath later industrial facades. I began with old engineering journals digitized by universities in Vienna, Budapest, and Warsaw. Several 19th century bridges share anomalies, substructures appearing more advanced than superstructures, stone piers with inexplicably perfect symmetry, sealed alcoves or chambers with no documented function. One bridge in Budapest, officially completed in 1877, includes a pier foundation photographed during low water in 1891, and the masonry visible in that photograph shares the same polished curvature found beneath the Stvanitz pier. A mining engineer observing it in 1891 wrote, "Stonework unusually smooth, resembles earlier fortification remnants." Fortifications, or perhaps something older. I expanded to structures farther east. Old maps of Kazan from the 1870s show a network of subterranean vaults beneath what is now the old Tatar Quarter. Some of these vaults, documented before Soviet reconstruction, display circular geometries nearly identical to the erased chamber in Prague's 1897 blueprint. The deeper I looked, the more the pattern emerged: circular subterranean chambers, precision stonework without chisel marks, hydraulic alignment to river flow, symmetrical radii recurring across thousands of kilometers. Official records describing them as older foundation remains or unclassified masonry, all present beneath structures built between 1860 and 1910. The geographical spread mirrors regions labeled Tartaria, Great Tartary, or Tartaria on 17th, 18th century maps, territory spanning from Central Europe to Siberia. On these older maps, Tartaria appears not as a vague cartographic placeholder, but as a defined territory with cities, infrastructure, and governance. Alternative researchers argue these are remnants of a unified Tartarian infrastructure network, hydraulic systems predating modern industrial capability. They suggest that what we call the 19th century's Industrial Revolution was partially built atop and integrated with a pre-existing Tartarian water management grid. Official historiography rejects such interpretations, viewing Tartaria as a cartographic shorthand, not a civilization. Yet physical evidence, stone, symmetry, engineering logic, does not bend to narrative convenience. Something links these structures. I returned to Prague with one question resonating in my mind: how many modern bridges and buildings stand atop inherited Tartarian infrastructure we no longer understand? The pattern was no longer subtle, it was architectural, geographic, and unsettlingly consistent. I returned to the bridge in early spring, just after a night of heavy rain. The river had begun to recede, exposing the lower masonry for a few short hours. I carried with me a copy of the 1897 substructure blueprint, its erased circular chamber freshly annotated in pencil. My goal was simple: determine whether any physical evidence of the chamber remained. And the eastern pier looked ordinary from a distance, but once I stepped beneath the approach, the texture of the stone shifted. The upper courses showed typical late 19th century tooling, visible chisel marks, slight irregularities, mortar lines. But 6 rows below, the stone becomes unnervingly smooth. Water slides off it without clinging. The surface reflects light even under cloudy sky. Then I noticed something I had missed before. A hairline seam running horizontally, nearly imperceptible, traces across the smooth masonry. Kneeling, I pressed gently. The seam flexed, not like a crack, but like a fitted joint. The stones form a hinged plane, although there is no record of any access panel or vault entrance beneath this pier. My flashlight revealed rust along the seam, thin, almost dust-like, and when I followed it downward, I found a gap just wide enough to glimpse darkness behind the stone. The air coming from the gap was dry beneath the riverline. That alone is impossible. Any cavity beneath the river level should be humid, if not flooded. Instead, the air had the faint mineral smell of long sealed rooms, akin to cellars built centuries ago. I cross-referenced the location with the erased element on the blueprint. The gap aligns exactly with the upper curvature of the circular chamber. I attempted to measure the seam's radius. It matched 6.8 meters, the dimension erased on the blueprint. Why would a 19th century pier contain a dry internal chamber sealed behind precision-cut stone? No official document acknowledges this sublevel. It is entirely absent from Vlasak's construction logs. But the engineering logic suggests a pressure chamber, a vacuum or hydraulic regulator, yet no bridge of this scale required such complexity, unless it wasn't built for the bridge, unless the chamber served a function within a larger Tartarian hydraulic grid, and the Victorian bridge merely incorporated its remnants. This was my note that evening. The chamber is real, and it is older than the pier. The contradiction had matured from curiosity into physical encounter. To understand why the chamber had been sealed, I reviewed renovation files spanning 1902 to 1933. Most were routine: stone replacement, reinforcement after floods, minor structural adjustments. Then I found the 1924 reconstruction ledger tied to repairs overseen by engineer Yaroslav Havelka. Unlike earlier ledgers, and this one contains multiple references to removal of obsolete components. One entry, dated 12th of October 1924, reads, "Ironwork beneath east approach removed, function indeterminate, possibly part of earlier waterworks." Another describes closing of substructure voids using brick fill and cement, ordered to prevent public access. The phrasing, voids, is plural. A folded appendix was tucked behind the ledger, a preliminary diagram of the substructure, hand-labelled in haste. 3 voids are marked beneath the eastern pier. Only one aligns directly with the erased circular chamber. The other 2 appear connected by thin lines, channels, running toward the river. If these channels once functioned as hydraulic regulators, they have no place in a simple service bridge. Havelka's personal notes provide more context. He writes, in cramped script, "Interior stone too smooth, seems older than bridge itself, wears differently from outer courses," and later, "Iron wheel removed from cavity, no known purpose, possibly remnant of early millworks." But there was no mill here, no record of industrial machinery on Štvanis Island predating 1850. And the dimensions of the iron wheel described to be diameter approx. 3 meters are far too large for any known mill used in the region. A 3-meter wheel matches the scale of pressure-regulating turbines from late 1800s hydro-powered stations, or, uncomfortably, the types of components alternative researchers cite when discussing supposed Tartarian hydro-mechanical systems, claiming they once regulated large-scale water networks spanning the territories visible on old Tartarian maps. I am careful not to adopt their conclusions. Yet the physical evidence, large-scale, precise, undocumented, requires acknowledgement. The appendix ends with a troubling note: "Final directive, fill and seal, no further surveys required." Why seal a system instead of studying it? The silence of official documentation feels deliberate, or perhaps it is nothing more than neglect, an older system too inconvenient to explain, too complex to integrate into the simpler narrative of Victorian industrial progress. But the pattern persists. Buried infrastructure, removed machinery, unexplained chambers, each one a contradiction between the official historical narrative and the physical past the bridge seems to conceal. I laid out every map, photograph and blueprint I had collected across the table in my apartment. The winter light filtered through the curtains, dim and patient, as though waiting for me to notice something obvious. Beginning with Haverda's 1896 photograph, I traced the curvature of the exposed masonry. I compared it to the chamber radius on the erased blueprint, to the vertical channel visible beneath the pier, to the sealed doorway, to the measurements of foundations in Vienna, Budapest, Warsaw, and Kazan. Patterns emerged slowly, like a watermark coming into view. All structures showed recurring radii. The 427-meter surface curvature. The 6.8-meter internal chamber diameter. Minor channels spaced at proportional intervals. These proportions recur in hydraulic systems, not decorative architecture. All sites were originally near major waterways, Prague's Vltava, the Danube, the Vistula, the Volga. Water alignment is too consistent to be incidental. All anomalies involved smoothed stone beyond industrial-era machining norms. All contained circular or domed geometry underground. Domes compress load efficiently but appear out of place beneath modest bridges. All regions appear in maps labelled Tartary, Great Tartary, or Tartaria, prior to their redrawing in the 18th century. This last detail gave me pause. I do not accept the sweeping claims of alternative history forums, yet the overlap between these architectural signatures and the old cartographic boundaries was clear. I turned to the 1766 Robert de Vogondy map where Grande Tartarie spans far into modern Russia and parts of Eastern Europe. Many of the cities hosting anomalous structures lie within or along the edges of these boundaries. Then I noticed one more detail that made me lean back in my chair. On the 1766 map, the Vltava River is drawn with exaggerated curvature, flowing through an area marked Ancient Hydraulic Works. Historians dismiss this as decorative cartography, an attempt to fill map space. But the phrase echoed the 1889 journal entry describing subterranean hydraulic cavities. Two documents separated by a century using eerily similar language. The geometry beneath the bridge is not unique, it is part of a pattern that does not match 19th century engineering. At the margin of my notes, I wrote the quiet observation I did not want to admit. These structures behave as though they belong to an older hydraulic network. One not documented, not acknowledged, perhaps not even recognized by the builders who inherited its remains. Whether that network was Tartarian or something else is beyond proof, but the pattern exists. And patterns rarely lie. By analyzing the erased blueprint with imaging software, I isolated faint ink patterns beneath the surface. The circular chamber appears to have had an upper dome, a shallow, concave shell, consistent with pressure modulation rooms found in large hydraulic systems. Domes distribute force evenly. Water pressure beneath a dome becomes manageable, channeled into predictable vectors. Such design logic is absent from small industrial bridges, but common in large-scale hydromechanical complexes. The dome's design matches three characteristics associated by some scholars, not mainstream historians, but methodical architectural analysts, with supposed Tartarian engineering: mathematical precision, dome radius 3.4 meters, chamber radius 6.8 meters, perfect 1.2 ratio, concentric construction layers. Faint lines visible in the erasure show alternating courses of heavy stone and lighter aggregate. North-south alignment. The erased diagram aligns the dome's apex with magnetic north, not true north. No 19th century European engineering manual mentions magnetic alignment for substructure domes, yet several surviving underground chambers in Kazan, Omsk and Tobolsk, all within historical Tartarian map regions, show magnetic alignment. Tartarian researchers argue this reflects a unified design philosophy, a standardized approach to hydraulic infrastructure that transcended regional variation. I hesitate to accept the alternative hypothesis, but architectural parallels are difficult to dismiss. Further photogrammetric analysis of the pier revealed subtle outward curvature along its lower stones, identical to the load distribution patterns found in Lisbon's pre-1755 hydraulic domes, a system largely lost after the earthquake and later reconstruction. This raised another uncomfortable question. Why would a minor Prague bridge display engineering fluency associated with far larger and far older infrastructure. When I attempted to reconcile the official records with this emerging interpretation, I found no overlap. The records describe a simple truss bridge over straightforward masonry piers. Nothing more. Yet the physical evidence points to a complex substructure, sealed and overwritten, its purpose obscured. The pressure dome hypothesis was not something I wanted to entertain, but architectural logic forced me to. The dome beneath the Stvanitz Bridge may not be Victorian at all. It may be inherited from a Tartarian hydraulic system, a fragment of infrastructure predating the Industrial Revolution, built with techniques and knowledge we no longer possess. I returned to the river at dawn when the city was quiet enough that the bridge's faint resonances, metal contracting, water shifting, were audible. I brought with me a copy of Havelka's 1924 appendix, the one marking 3 voids beneath the pier. My goal was simple: determine if any structural trace of the iron wheel he removed still existed. At low water, a depression in the stone caught my attention, its shape a semicircle carved cleanly into the smooth inner course of masonry. When measured, the radius corresponded precisely to a 1.5-meter half arc, implying the original iron wheel's diameter of about 3 meters, matching Havelka's note. The indentation is not decorative, it is load-bearing. It shows pressure wear, uniform, directional, mechanical, something once rotated here. Not a Victorian-era water wheel, those require open flow, not sealed chambers, nor a mill component. Mills demand clearance and maintenance access. This indentation aligns exactly with the central axis of the erased circular chamber. Whatever machinery once occupied this space operated internally, beneath river level, in darkness. I compared its proportions to devices found in historical hydroregulation systems, not European ones, but the massive subterranean pressure turbines documented in pre-1917 photographs of the Nizhny Novgorod hydraulic vaults. Those vaults, now sealed, also feature circular chambers with heavy stone domes and similarly sized wheel recesses. Architectural analysts on the fringe, careful ones, not sensationalists, often cite these vaults as remnants of what they call Tartarian hydraulic stations, sophisticated networks that allegedly regulated water flow across broad Tartarian territories. They argue that these systems represent lost engineering knowledge suppressed or forgotten after the collapse of Tartarian civilization. I do not claim that connection as fact, but the physical similarities are difficult to ignore. The Prague indentation lacks any anchor bolts or mount points consistent with 19th century machinery. Instead, its support geometry matches older stone-inset rotary systems, machines whose engineering fluency exceeds that of the modest bridge constructed above them. The contradiction had become structural. Before leaving, I placed my fingertips inside the semicircle. The stone was unnervingly smooth, not polished, engineered. A precision finish inconsistent with the rougher Victorian courses above it. My note from that morning reads, "The wheel existed." Its purpose was not Victorian, and the pier was built over its ghost. The broader pattern fully emerged only when I revisited my cross-continental notes. I began charting each site with anomalies: Budapest, Vienna, Warsaw, Kazan. Then I added smaller entries, structures too minor to matter historically, yet sharing the same traits: sealed sublevels, smoothed stone, circular cavities. A pattern formed not just architecturally, but chronologically. Between 1900 and 1930, every one of these structures underwent renovations that removed internal components, sealed chambers, or replaced older foundations with newer stone. These renovations were carried out by different municipalities under different political circumstances, yet the actions were the same. Remove internal ironwork of unknown purpose. Seal circular cavities, brick over alcoves, replace smoothed stone with rougher courses, erase anomalies from blueprints. This was not a coordinated effort, at least not bureaucratically. It felt more like a shared discomfort, an inability or unwillingness to understand the older Tartarian systems engineers encountered. In Budapest's 1921 maintenance notes, I found subterranean cavity sealed due to lack of relevance to present structure. In Warsaw's 1908 inspection report, removed unidentified wheel from sub-pier recess, material intact but no functional integration with bridge. In Kazan's 1914 reconstruction file, suspended dome section appears pre-existing, sealed to stabilize footing. Every record echoes Havelka's phrasing in Prague. Engineers across nations encountered the same inexplicable infrastructure and reacted identically. Remove, seal, overwrite. This is not malice, it is confusion. Yet the erasure was systematic, not orchestrated but repeated. The official narrative of ordinary 19th century construction overwrote a deeper, older Tartarian reality. These structures did not begin as industrial bridges or municipal buildings. They inherited something prior: smoothed stone, hydraulic geometry, domed chambers, mechanical recesses, all signatures of what Tartarian researchers identify as Tartarian infrastructure. The more I mapped, the more the boundaries coincided with pre-18th century maps labeled Tartaria. Not perfectly, but significantly. When I finished overlaying all sites onto a single composite map, the alignment was uncomfortably clear. The Vltava, the Danube, the Vistula, the Volga, all major waterways running through old Tartarian territories, all hosting structures with identical anomalies. My quiet internal note: we have been renovating over a forgotten Tartarian system without recognizing its scale. As I walked again beneath the Stvanitz Bridge, the early light reflecting off the Vltava, I felt the architecture differently, not as a structure built in 1898, but as a palimpsest, overwritten but not erased. Above me, riveted steel trusses of ordinary industrial design. Beneath me, masonry, older, smoother, more intentional. The bridge is not a singular structure. It is two timelines interwoven. The Victorian timeline, the one we can document, rests lightly atop another, heavier chronology. One built with Tartarian techniques absent from 19th century manuals, using stone finishes inconsistent with local quarries, aligned to magnetic north, structured around hydraulic logic beyond its supposed function. All characteristics modern Tartarian researchers attribute to a lost Tartarian civilization whose infrastructure we inherited but did not understand. The weight of the bridge is nothing compared to the weight of the unanswered questions beneath it. In the archive's dim reading room, I revisited the 1896 photograph, and this time I noticed something I had missed. In the shadow beneath the unfinished platform lies a faint glint of metal, a fragment of the iron wheel Havelka later removed. The wheel is half buried in silt, but its curvature is perfect, its spokes unusually thick. Behind it, the smoothed stone of the chamber wall reflects a thin line of winter light. No annotation accompanies the image. No engineer mentioned this object in their early notes. No historian commented on it. It remains in the photograph, silent and inexplicable, an artifact of Tartarian engineering without a history, a shape without a name, a reminder that beneath the modern world lies something older, sealed and unresolved, and that we have been building over Tartarian remains without ever understanding what we inherited.